Our last type of equations that we're going to look at solving are equations with variables on both sides. To solve an equation that has variables on both sides, we're going to use the addition or subtraction properties of equality to get the variables on one side of the equation. So similar to how we were solving our other types of equations, just we have to get the variable on one side and all the non-variable terms on the other. So let's look at some problems. Number one, we have k's on both sides of the equal sign. So again, it doesn't matter which side you have your variable on as long as it's all on one side. So I'm going to subtract the 5k. It's positive, so I have to subtract to get it to the other side, but I chose to do that so then my variable term is positive. 7k minus 5k is 2k, and then I'm going to bring down everything else. Now to solve for k, we're going to add 4 to both sides. 16 and 4 is 20. And then divide by 2. So k equals 10. Okay, number 2, we have to distribute first, right? Clear parentheses. So we have 2c minus 12 equals 9c plus 2. Then we have to get our c's on one side. I'm going to subtract 2c from both sides, so therefore I have a positive variable term. Okay, bring down everything else we haven't used yet. Then we need to solve for c, so we'll subtract 2. Negative 12 minus 2 is negative 14. That equals 7c. So lastly, divide by 7. Negative 14 divided by 7 is negative 2. So negative 2 equals c. All right, let's do some more. Okay, well, in number 3, the 3m is by itself, so I'm going to bring the 1m to that side. Now you always go by the sign in front of the number to know whether you're going to add or subtract. So since m is positive, I'm going to subtract m. So we're left with negative 5 equals 2m. Divide both sides by 2. 2 does not divide evenly into 5, so you can leave it negative 5 halves. You can write it as a decimal since it's a decimal that terminates, but leaving it as a fraction is perfectly fine. Okay, number 4. So to get a positive variable, I'm going to add b to both sides first. So then we have 7b plus 14 equals negative 7. Solve for b, so let's subtract 14. 7b equals negative 21. Divide both sides by 7. b equals negative 3. There are special cases with equations as well. An equation has no solution if no value of the variable makes the equation true. So for example, 2x equals 2x plus 1. If you were to solve for x, like you subtract 2x, they cancel out on both sides, you're left with 0 equals 1, which that is not true. So therefore that equation has no solution. There's no number you could substitute in for x to make it true. Now an equation that's true for every value of the variable is known as an identity. So if you were to subtract 2x from both sides, you'd get 0 equals 0, which is true. Or you could have seen, 2x equals 2x is exactly the same on both sides, so that's an identity. We can say that this would also be all real numbers, that any real number you substitute in would make that equation true. And then if you want to say the set of all real numbers, you just make a capital R like that to mean the set of all real numbers. Okay, the last two problems we're going to determine if we have an identity or if we have no solution. So number 5, we want to get our n's on one side of the equal sign. So if we subtract 5n, well, we notice 5n minus 5n 0, 5n minus 5n 0. So we're left with 9 equals negative 1. Well, 9 and negative 1 are not the same. So they are not equal. This would be no solution. And for number 6, let's clear parentheses first by distributing. So we have 4 minus 4y equals negative 4y plus 4. If I add 4y to both sides, okay, so those cancel out, these cancel out, we're left with 4 equals 4. And that is true. So that is an identity. And our answer would be the set of all real numbers. So any number we plug into that original equation will make it true.